For a max, the derivative has to do this. Positive, negative. Is it negative?
No.
No. So it's nothing. What about 0 comma the cube root of 4? What type of point is 0 comma the cube root of 4?
Max.
Yes, local max. What about 2 comma 0? What type of point is 2 comma 0?
None.
Nothing. Exactly. Nothing. Nothing. There is a critical number there, but it does not turn into a max min. Okay, the next topic, you can stop me anytime and we can work on more problems. I see I have another chat. Yes, good. So let me share my screen. I'd like us to move on to closed intervals. So we already discussed that the absolute max min can happen at the endpoints of the interval, but not local max min. So let's choose anything from here and study the function finding its absolute max min on a closed interval. And this is a calculator issue. This is just the same thing. We have to set it equal to 0. Okay, so we can continue. So let's choose. I couldn't hear you, Isaac. I'm sorry.
Number 66.
66. 66. Very good. So we have f of x equals x minus 2 arctangent x on the interval 0, 4. Excellent. Well done. Good pick. Oh, there was a chat. 66. Well done. Both of you chose 66. It must be important. Okay. So the same, everything the same. Please get used to it. You're going to see it for the next 6 sections every time. So f prime of x, f of x, 0, 4. Nothing else. This is given to us. Nobody's asking you about the domain for these type of functions or problems. Okay, so then I have to find f prime. Can anyone help with f prime? Anyone?
One plus. Oh, sorry.
That's specifically why I wrote it like this, not to be confused with a function raised to -1. Close. Good. So this is then x squared. Sorry. So this has to be multiplied by x squared plus 1. And we have x squared plus 1 minus 2 divided by x squared plus 1. So this is x squared minus 1 over x squared plus 1. And we have two possibilities here. One for f prime being 0, and one for f prime being undefined. Let's start with this one. Where is this function undefined, if any?
One. And -1. Oh, no, wait. No, I'm sorry. No, it's never undefined.
Excellent. Well done. Where is this function 0?
X equals 1. Or x equals -1.
Or both, right? Because it's quadratic. Good. Well, -1 is not in our domain, so -1 is right here. Who cares? It's outside. But 1 is inside. At this point, so I put 0. At this point, I will study the sign of the derivative to the left of 1 and to the right of 1. Okay. So plug in 0, because 0 is between -1 and 1. And tell me just the sign. I don't need any number. I only need the sign of this expression when x is 0, and the sign of this expression, let's say, when x is 4, or when x is 2, when x is 3, or 10, or 1500. Doesn't matter.
When 0, it's negative.
Very good. Indeed. It's -1 over 1. And on this side,
Positive.
that's it. At this point, I put this function in the graphing calculator, and I have to determine these 3 values. And then we will make a decision. I'm going to share my screen. My calculator is ready, believe it or not. Yes, any questions, please ask.
I had one, but like I understood.
Say it again.
I had a question, but like I just answered it by myself, so I understand.
I love it. Less work for me. Just kidding. Okay, so second in table, I have the function in, and I want 0, I want 1, and I want 4. And I have to make absolutely certain that the mode is in radian. If I have the mode in degrees, I have to do it again. I have to do it again. It may automatically do it by itself. It does it. Very smart. Thank you, calculator. So for 0 is 0. For 1 is -0.6. For 4 is 1.3. Well done. Thank you, calculator. Okay, because remember, I plugged in numbers. Well, actually, hold on. Hold on. Hold on. So sorry. So sorry. In arctangent, I have to plug numbers in, of course. But it doesn't matter. Yes, I am plugging in numbers. It doesn't matter. The mode does not. But let me see for a second. Why did it give us? Because in hold on, in arctangent, we plug in numbers. It's not tangent, it's arctangent. So we plug in numbers. Why would it make a difference? I have to think on this for a second. I can move on before I think for a second. Why would it make a difference? Because they are numbers. Yes, because of X. I got it. Okay, let me explain. Got it. Because of this. That is the difference. Okay, so the numbers are between 0 and 4. So I don't plug in degrees. That's why it has to be in radians. So for this will not make any difference. The difference is here. I don't plug in degrees, I plug in numbers. So that's why it has to be in radians because of that. For this, it should not, so this is x in arctangent. So remember, arctangent, we graphed it several times. Arctangent is this. And it's between -pi/2 and pi/2. So that's why I have to plug in. It's between negative infinity, infinity. So the range is between -pi/2 and pi/2. So I'm getting for arctangent the answer is in radians. Otherwise, it would be in degrees. And x has to be in radians. That's the reason why. Okay, so back to, so back here. So now this is the moment of truth between these two. This is when I make sure that they work in sync together well. Okay, from 0 to negative 0.6, what does the function do? It decreases, and that's what the first derivative is telling us. It's decreasing. From negative 0.6 to 1.3, the function is increasing, and that is true. From negative 0.6 to 1.3, the function is increasing. And now we have to make a decision. What type of point is 0, 0, 1, negative 0.6, and 4, 1.3? So I'm going to list them here one more time. I'm just going to show you 1 second here. I'm not graphing the function or anything. I'm just saying 0 is here, negative 0.6 is here, somewhere lower, and 1.3 is here. I'm not graphing the function, but this is 0 and then negative 0.6 and then 1.3. So now this is easier to identify what they mean. So what is 0, 0? This point, and then this point, and then this point. What does 0, 0 represent? And I'm going to write it here. Nothing. So look. This is at the end point. It can never be a local. It's not the highest, it's not the lowest, so it's nothing. What is this point?
Minimum.
Yes, it's local and absolute. Oh, where am I here? Local and absolute minimum. What about 4, 1.3?
Nothing.
Say it again.
Nothing.
But it's the highest value of the function. That's why I graphed them. I plotted them here. 0 drops to this, goes up to 1.3. So what type of point is 4, 1.3?
Local max.
Say it again.
Local max.
It cannot be local because it's at the endpoint of the interval. It's at the endpoint of the interval 0, 4. This can never be local. This can never be local. The endpoints can only be absolute, if anything. So from here till here till here. This is not the graph. I'm just showing you the heights. So what type of point is this? 4, 1.3.
Absolute maximum.
Absolute max. Absolute max. And this is the way we study a function, finding its max, min, absolute max, absolute min, on a closed interval. Very good pick. Thank you. Good. Would you like to look at another, or we move on? Oh. Okay. Yep. We can do another. If it's Christine, remember, you have your computer on Bluetooth. I think that's why, I guess. Okay. Anyone? Let's look at 55. It caught my eye. Because it's degree 4, so I don't know. I can't tell you what's going to happen with that. No idea. -2, 3. Good. Everything is the same. Where are you guys? Right here. Okay. Everything is the same procedure, is just a different function. Nothing different. And -2 to 3, f prime of x and f of x. We determine the derivative. So 12x to the third minus 12x squared minus 24x. Oh, I see. It's quite nice. Always remember, factor simplify. X squared minus x and minus 2. Very nice. It cleans up quite nicely. So this is x minus 2 and x plus 1. Good. This is just the algebra. I'm sure you have no difficulties with that. So what do I do next? No critical numbers will come from f prime being undefined. There is no such thing. This is polynomial. But can anyone solve this equation for us since it's degree 3? Please give me 3 solutions. Anyone?
X equals 0.
Yes?
X equals +2 and -1.
Excellent. And now I'm going to see if they fit in there. -1, yes. 2, yes. 0, yes. Good. Now I will have to determine these 5 y values for these x values. So let's go back. I share my screen and y equals clear. And I will enter 3x to the 4th and minus 4x cubed and minus 12x squared and then plus 1. And I think I don't need the battery now. Okay. And we go to second and table. And I want -2. I want -1. I want 0. I want 2. I want 3. Okay. So for -2, 33. For -1, -4. For 0, 1. For 2, -31. And for 3, 28. Perfect. I'm going to stop sharing. Okay. So now, the moment of truth. At this point, for this particular problem, I don't really need this, but we have to get used to it. It's extremely, extremely important.